Section 9.5, adding and subtracting rational expressions. In previous sections, we have done operations with rational expressions. Now we're just continuing that with adding and subtracting them. Here's our procedure. We want to factor the denominator if possible. We want to determine the least common denominator. We want to multiply each fraction by identity to get each fraction with the LCD. In other words, we want to multiply the top and bottom of each fraction by the same expression, which is the identity. Therefore, we'll change the look of that fraction, but not change the value of it. Then we want to perform the indicated operation, and remember, don't forget to distribute if needed. And of course, we always want to simplify the final solution. Let's take a look at some basic examples that we have done in just arithmetic. So when I have a basic fraction, 2/5 plus 1/5, I have common denominators. Therefore, I'm allowed to add these two fractions. I add the numerators. 2 plus 1 is 3 over 5. And I determine if I can simplify that. Since I can't, my solution is 3/5. In this example, I have 1/4 minus 2/3. As you can see, I need to find a common denominator. The common denominator between 4 and 3 would be 12. So I just rewrite 1/4 minus 2/3. And I multiply this fraction by a value of 3 over 3 to get my denominator to be 12. And this fraction by 4 over 4 to get my denominator to be 12. As you can see, I multiplied by the identity, which will change the look of my fraction, but not the value of my fraction. In other words, I multiply the top and bottom by the same value. And when I multiply, that's going to give me 3/12 minus 8/12. Now I perform the operation. 3 minus 8 is going to give me a negative 5/12. I check to see if I can simplify, and since I can't, that is my solution, a negative 5/12. Now let's take a look at a rational expression. That's no different than the previous page. Here I have common denominators, which means I can perform the indicated operation. In this situation, a negative 5 minus 4. So that means same sign combined. I'm going to combine the numerators, which will give me a negative 9, over the common denominator, which is 3x. Now I would check to see if I can simplify. And of course, 9 and 3 can simplify. 3 will go into both, and that will give me a negative 3 over x. Very similar to our basic arithmetic of fractions. In this example, I have 3 over 2a plus 2 over 4a squared minus 1 over a. I need a common denominator. Let's begin with the coefficients, 2, 4, and 1. A common denominator between 2, 4, and 1 would be 4. Now I need a common denominator with the variables. And my common denominator with variables will always be the largest degree. I can take a to a squared. I can take that a to get a squared. So my common denominator overall would be 4a squared. Now let's just rewrite. 3 over 2a, leave a space, plus 2 over 4a squared. I'll leave a space, and 1 over a. Now I just want to multiply each fraction in such a way to get a common denominator of 4a squared. In this problem, I'm going to multiply by 2a over 2a. In this fraction, I'm set with a common denominator of 4a squared, so I can leave that alone. And the last one I can multiply by 4a over 4a. And now when I simplify each product, I'm going to get 6a over 4a squared plus 2 over 4a squared minus 4a over 4a squared. Now I can rewrite that all over 4a squared because I have a common denominator, and I simplify the numerator by combining like terms. 6a minus 4a is 2a plus 2. And as I stated, I need to see if I can simplify. I can factor a 2 out of the numerator, and when I do, that's going to give me 2 times a plus 1 all over 4a squared. And now the 2 and the 4 can simplify. 2 goes into 2 once, leaving me the numerator of a plus 1 over 2a squared. Here's another example, and as usual, I need to find a common denominator. Let's begin with the coefficients. Between 3 and 4, a common denominator would be 12. For the variables x squared and x, I need to take it to the largest exponent, therefore x squared. And between y and y squared, again, to the largest exponent, which would be y squared. Now let's just rewrite each fraction. 3y minus 1 over 3 x squared y, leave a space, plus 2x plus 3 over 4xy squared. Now let's multiply each fraction in such a way to get a common denominator. Therefore, I need to get 3x squared y to be 12x squared y squared. Therefore, I can multiply by 4y in the denominator and numerator. In this fraction, I need to get 4xy squared to become 12x squared y squared. Therefore, I'll multiply the denominator by 3x, and therefore multiply the numerator by 3x. And what I need to do is to simplify by distributing into my numerators. And when I do that, I'll have a denominator in this problem of 12x squared y squared. And when I distribute, that's going to give me 12y squared minus 4y plus, and when I distribute again here, 3x times 2x is 6x squared. 3x times 3 is 9x over 4xy squared times 3x is 12x squared y squared. Now I need to combine like terms because I can write this over my common denominator, which is going to be 12x squared y squared. And when I combine like terms, I notice that I don't have any combined like terms. Therefore, I just write 12y squared minus 4y plus 6x squared plus 9x. Then I check to see if I can factor something out of the numerator. I check the coefficients, 12, 4, 6, and 9. There's nothing common that can come out of there. Of course, y squared, y, x squared, and x. Nothing that can come out of there. And therefore, this is my solution. In my next example, I have a negative 1 over 2xy minus 2x over 2x squared plus 6x. First procedure is to factor the denominator. That gives me a negative 1 over 2xy minus 2x over, when I factor the denominator, I'm going to get 2x is what I can factor out. That leaves me with x plus 3. Now I can determine my common denominator. I have a 2x and a 2x. I need a y and a y here, so I need to have a common denominator of 2x y times the quantity of x plus 3. Now I just rewrite my fractions, which is going to be a negative 1 over 2xy, leave a space, minus 2x over 2x times x plus 3. I need to get this denominator, 2xy, to be 2xy times x plus 3. So I'm going to multiply the top and bottom by x plus 3. My denominator here is 2x times x plus 3. I have the 2x, I have the x plus 3. Therefore, I need to multiply by y over y. Let's simplify each product. On the numerator, I'll distribute. That would be a negative x minus 3 over 2xy times x plus 3, which is my common denominator, minus 2x times y is 2xy over 2x times y is 2xy times x plus 3. Now I can rewrite this all over a common denominator, and that will be 2xy times x plus 3, and then simplify the numerator. Negative x minus 3 minus 2xy. I check to see if I can factor out of the numerator or then simplify, but I have nothing to factor, therefore this is in simplest form. My next example, a negative 1 over x squared minus 4 plus 9 over 3x plus 6. Let's factor the denominators, and when I do, that's going to be a negative 1 over, difference of squares, x plus 2, x minus 2, plus 9 over, factor out of 3, and that leaves me x plus 2. My common denominator will be 3 is in this denominator, but not here, so it'll be 3. X plus 2 is here and here, x plus 2. Also, x minus 2. So this is my common denominator. Let's rewrite our fractions. Negative 1 over x plus 2, x minus 2. I'll leave a space, plus 9 over 3 times x plus 2. We need to get this denominator to be this common denominator, so I'm going to multiply by 3 on the top and bottom. And this denominator needs to become this common denominator, so I'll multiply by x minus 2. So I'll simplify. Negative 1 times 3 is a negative 3 over 3 times x plus 2, x minus 2, plus, and here I can distribute. 9 times x is 9x. 9 times a negative 2 is a negative 18 over the common denominator of 3 times x plus 2, x minus 2. Now I can simplify and rewrite them over the common denominator. And my common denominator is 3 times x plus 2, x minus 2. And let's simplify the numerator by combining like terms. 9x and a negative 3 and a negative 18 is a negative 21. I can factor the numerator. I can pull out a 3. And when I do, that's going to be 3x minus 7 over 3 times x plus 2, x minus 2. And I can simplify the 3's and cancel those out. And my final solution will be 3x minus 7 over x plus 2 times the quantity of x minus 2. In my next problem, again, I need to factor. So let's rewrite 3x minus 2. Factor the denominator. That will be x minus 4 times x plus 3 plus x plus 3 over x minus 4. My common denominator will be x minus 4 times x plus 3. So when I rewrite, I have 3 x minus 2 over x minus 4 times x plus 3 plus x plus 3 times x minus 4. I already have the common denominator here, so now all I need to do is multiply this fraction by x plus 3. And when I do, that gives me 3x minus 2 over x minus 4 times x plus 3 plus, here I can FOIL, which will give me x squared plus 6x plus 9 over the common denominator, which is x minus 4 times x plus 3. I can write that all over the common denominator, which is x minus 4 times x plus 3, and simplify on the numerator. That gives me x squared, 3x plus 6x is 9x, and a negative 2 plus 9 is 7. I'd look to see if I can factor in the numerator to simplify. Since it doesn't, that is my solution. Again, in my next example, I want to begin by factoring. So I bring down my 3x, which I can write that over 1 because I know it is over the denominator of 1, minus 4x minus 3 over, when I factor here, I get 2x. When I factor out, that leaves me with x plus 2. My common denominator is going to be 2x times x plus 2. I already have that in this fraction, so I need to multiply this fraction by that quantity. So that will give me 3x over 1 times 2x times x plus 2 over 2x times x plus 2 minus 4x minus 3 over 2x times x plus 2. When I simplify this product, that's going to give me 6x squared times x plus 2 over 2x times x plus 2 minus 4x minus 3 over 2x times x plus 2. We can simplify and rewrite that over the common denominator. So that will give me 2x over x plus 2. And now I can distribute the 6x squared, which will give me 6x cubed plus 12x squared. And I can't forget, I need to distribute that minus sign, or that negative. So that's a negative 1 times 4x, which is a minus 4x. And a negative 1 times a negative 3 is a positive 3. Now I check to see if I can factor something out of the numerator. I can't factor any variables, and I have no common value that I can factor out. Therefore, this is simplified. My next example, again, I want to begin by factoring. That gives me x plus 2 over x plus 3, x minus 2, minus x minus 5 over 3x and x, and then I'll have a plus 4 plus 3. I can verify that because 4 times x is 4x, 3 times 3x is 9x, 4x and 9x gives me my 13x. Now I have a common denominator. Here is an x plus 3 and an x plus 3. So my denominator will be x plus 3, x minus 2, and 3x plus 4. So I can rewrite x plus 2 over x plus 3 times x minus 2 times, to get a common denominator, I need to multiply by 3x plus 4 over 3x plus 4 minus x minus 5 over 3x plus 4, x plus 3, and I'll need to multiply by x minus 2 over x minus 2. And then I will need to FOIL in the numerator. And when I do, that's going to give me 3x squared. My outer is 4x. My inner is 6x, which is going to give me a plus 10x. And my last is plus 8 over x plus 3, x minus 2, 3x plus 4, minus x minus 5 times x minus 2. And when I FOIL, that's going to give me x squared minus 2x minus 5x is minus 7x plus 10 over 3x plus 4, x plus 3, and x minus 2. Now all I need to do is to combine like terms. And I'll fit that right into that open area. So under a common denominator of x plus 3, x minus 2, and 3x plus 4. In my numerator, I'm going to have 3x squared minus x squared, which is going to give me 2x squared. 10x plus 7x when I distribute, which is 17x. 8 minus 10 when I distribute, which will give me a negative 2. So don't forget to distribute. If you have to, you can put parentheses here to remind you that you must distribute that negative 1 through each term. Now I check to see if I can factor in the numerator, and since I can't, this is my solution.